welcome back to the Dear Global Leader podcast. So today I have a new guest. This is Marie Piraud, and she's the head of AI consultant at Helmholtz AI, which is the largest German, but also one of the largest European scientific research organization. And Marie focuses her work on artificial intelligence applied to science. And she's leading a team of 15 data scientists and ethics specialists focusing on application on the health. You also have published 40 research paper and be coded in more than 8,000 research papers. So this is really impressive. And along your career, you also receive different grant and award to continue this journey. So I'm very honored. And today we'll, of course, discuss AI. So the format will be slightly different. This time I will have two parts. So the first part will look and deep dive a bit more into the insights of working with AI at such a big research company. And later we will look into AI and leadership. So my first question, usually I'm always starting with like, what is the biggest pivot that led you where you are? And actually know that you started researching quantum physics and then you arrived to AI. So how did this transition happen for you?
Hi, so first, hi, and thanks a lot for having me here. My career shift, I think it's more coming a bit from personal reasons. I was really excited about quantum physics and the research I was doing there, but I decided to change because I was feeling a bit too. I was in a very special. I was a very specialist, and I was in a very narrow field and a very narrow track with basically one single career path. And I decided to broaden my horizons and like basically also possibilities. And that's why I decided to change. So it's more of a personal reason. I entered the field of AI basically in 2016, where was kind of the beginning of the hype, let's say.
Mm,
So it was actually a very good timing because everybody was new to the topic. So it was okay to be also new to the topic. Everybody was coming from
mm,
all different directions to the field, and because I had a bit more seniority already in
mm,
research, because
mm,
I was already I had already done a postdoc and so on. So I knew just knowing how to do research, and I also had different tools like mathematical tools, computational tools coming from my physics background. This worked really well. So the timing was quite good.
that's super interesting because as you were saying 2016, so you were at the premise where some people, I talk AI and they said I worked in AI before that AI was a thing. So you were maybe at that time. And how was it for you also to be part of something that then became, you knew that for such a long time and now AI is booming and for you it's like 10 years later. How do
It
you,
depends.
yeah.
So it depends when you define the boom of AI. But I would not claim that I was working on AI before AI was a thing. I think I just started, at least in research and in the field, for example, of medical imaging.
Mm-hmm.
I started exactly at the time when it started to be a thing. So I in this field, I never, used the classical approaches to medical imaging, for example. So I would
Okay.
not claim that.
Yeah,
I
but
think I
that's
just
interesting.
starting the wave right exactly at the right time. But
That's
for the general public, of course, like this ChatGPT and so on, this
mm,
was later. Yeah.
yeah, and I get health is also developing so fast that maybe you know so much more than what the customer sees at the moment. What would be interesting because it can start to become very technical first without that some people understand a bit what you are doing. Usually we look at the behind the scenes in this podcast. So I wonder if you can just explain, who usually called you for some projects and what are usually the type of subjects and how do you organize a bit the project from maybe not the A to B, but just what is the essence of the consulting work you are doing in AI? and medical application?
So yes, my team is a consultant team for research, but is also academia.
Mm-hmm.
So our clients are like clients. I should put it in brackets.
There are also
um,
research companies, I guess.
they are researchers. No, they are in like
Mm.
individual research groups. So they are not companies. They are
Mm.
academics, researchers, and they approach us, and usually in the framework, like the collaboration takes place in the framework of a standard research collaboration. So there's no money involved, like money transfer. They're not paying us. We are not paying them.
Mm-hmm.
But we both together invest time into a research project, and their expertise and our expertise are complementary. So they are specialists in their own research fields. They are usually acquiring data,
Mm-hmm.
and we help them analyzing and get the best out of the data
Mm-hmm.
with machine learning or AI. But it's really not a it's actually not a client customer kind
Mm.
of relationship. Yes, and then we have defined several phases for this consulting projects. So we usually have like a first contact, a first contact, and this can be maybe like either an email or a couple of emails, or
Mm.
maybe a half an hour interaction where we just check that the setting is clear for them, that exactly what I described. This is going to
Mm.
be a research collaboration. Everybody has to bring in something in the collaboration. We also check that the question is indeed related to machine learning,
Mm.
might be misunderstanding of what this is. And also that, yeah, and but the idea and the data comes from the collaborators. And then we have two stages. So the first one, the formal first stage, is called the what we call the exploration phase.
Okay.
And in this time, we usually it's a short, like we estimate 2 weeks full time. So
Mm-hmm.
it can take a bit longer, but kind 2 weeks of work where we really dive into the research question. So we make sure that we really understand the research question and then translate it into a machine learning task.
Mm-hmm.
So really making sure that we take a lot of time to do this process, that there is no misunderstanding on the expectations, also what
Mm-hmm.
the algorithm should do.
Okay.
And then we also take the time to review the literature, what is the state of the art for this task. And we kind of do, let's say, differential analysis between the literature, the state of the art, and what we actually have to
Mm.
achieve, and the data that we will have available. Sometimes there, yeah, and then we try to assess based on that, basically the feasibility of the project, kind of a risk gain analysis. So
Mm.
if we think it's risky, but also at the same time, if ever it works, it's awesome.
Okay.
Or
Yeah. Big
if
scale
if we
stakes.
think it's a low hanging fruit, yeah.
Mm-hmm.
And we kind of try to communicate that also to the collaborator, and then we decide together if we engage further into the project or not. That's yes. And then the rest of the consulting, we call it realization phase.
Mm-hmm.
uh, this is much longer. We also have estimation of like 6 months full-time
Okay.
work. Then it's more standard. It will be like an actual implementation, evaluation on implementation evaluation, like a data science project, and then review the results, and then cycle again, then change something, implement again, evaluate, and so on, in order to improve the solution until we
Mm.
reach we were hoping for. And then we also hand the code over, a
Mm.
small report on the methods, what we implemented, and so on, such that this is something that can really be leveraged by the collaborator and potentially also enter publications, for example.
Yeah, this is the question I wanted to ask because, I think a lot of us will be more I mean, less a bit far away of the research organization. And I just wonder if it's a research individual, for which purpose is it? Is it that this person will then sell it to a company, or just that I understand where all of this good material is ending at the end?
No, we are not selling tools to companies. I mean, what we are building also is not really products or bulletproof products, right? It's
Mm-hmm.
more like what in industries it would call the proof of concept, because we
Mm-hmm.
have um, a couple of users on one team, and it can. So it's not a bulletproof software. Um, and yes, typically the code and the results, they will be part of publications and
Mm-hmm.
also open sourced somehow.
Okay.
Uh, so it means that at least the code will be available on a GitHub repository. The model might be also on Hugging Face for everybody to use, for example. We sometimes integrate them into small tools, but also based on open source tools, such that any researcher that also wants to
Mm.
use it can use it for research, and actually anybody. But then it depends a bit on the licenses of the code might depend a bit, but typically it's free for use for research.
Mm.
But then for commercial purposes, you would have to contact
Mm.
Helmholtz Munich, my employer, and start a discussion.
Mm. So does it mean that then you have some sort of like an open source platform or base that all researcher can use and that they can build their knowledge, but then the company can still, through another of this research center, get access to this knowledge or implement it?
So also the results of the papers
Mm.
that we publish, they are also available to everybody.
Okay.
That's also a bit the spirit of academical research, that we are paid by the taxpayer money. So like the spirit is also that everything we do is to advance basically knowledge,
Mm.
but also goes back to the general public. So we really have kind of a mindset of putting things available
Mm.
as much as possible. So you can get by looking up the publications that we publish, you can basically know the results,
Mm-hmm.
and the code. You can also get it if you are able to run it. You can get it. It's all open source.
Mm-hmm.
Yeah.
And your team always existed within your organization? Because AI is still a developing
No.
topic. So how did came became like a research topic in such a big academic area now?
So my team started in 2020, and I started also in 2020.
Mm.
The idea of this consulting is not my idea, so it was originating before. It's like a general initiative
Mm-hmm.
from within the Helmholtz Association, seeing that generally digitalize, like all large organizations are digitalizing themselves, and also
Mm.
that AI will be a big thing. They had, I think, anticipated that a bit, and they decided to create those AI consultant teams. So there is 6 different consultant teams in
Mm.
Germany, each one having a different focus point. So my team is focusing on health and biology
Mm.
topics. And then the other consultant teams are focusing on other topics like physics. So
Mm.
everything is hard sciences, but physics, environmental research, and so on. Uh, and this idea originated several years earlier. They wanted to catalyze the use of AI in all those research fields, and then created the AI consultant teams.
And how did this go? Because we also have the parallel in companies when you want to reorg and do something new, and then there is a lot of change for some people. Did you go in? Did you experience that, or because you joined, you didn't really feel this phase, or even now maybe you're in a phase of growth?
So the consultant teams, we are an offer to the
Mm-hmm.
to the researchers. like we didn't disturb or induced, I think, a big transformation, because we are not kind of it's
Mm,
not a it's an offer. So and we definitely, I think, see that at the beginning, these early adopters that
mm,
coming to us, they were already aware
mhm,
somehow of AI, and they had some data, and they were basically early adopters and very enthusiastic and so on. And now we have the base of people who are aware what
mm,
AI can do and so on. This has exploded for
mhm,
sure. So I think the demand is definitely increasing. The team has also increased a lot. What I also wanted to mention, but I also see that the people that approach us now compared to 5 years ago, they are so much more aware of what AI can do,
mm,
but also they have often tried things out. So before approaching
mm.
us. So at the beginning in 2020, I don't think that we had a lot of collaborators who had tried.
Experience.
Yeah, they just were approaching us with bare data, and they didn't also know that they had to label the data, for example, or
Mm,
things like that. Whereas now they often have tried a few things themselves because there is so many tools available.
mm,
And then at some point they still reach a point where they cannot really interpret, or they don't understand what's going on because it's not like simple linear regression, let's say.
mm.
And then they reach out. So this has evolved, and yeah.
This was actually my question because I wondered, you mentioned data and cases a bit generalistic, and I'm not in that field, so actually, if maybe you can give some specific topic you're discussing on, and maybe tell me what type of data are brought, because I don't know, is there like a normal researcher that was researching medical imagery, you were mentioning it before, and then says, maybe I should see if AI could do something, or it's more someone that works in AI, it wants to apply it to med tech. You see what I mean? It's like, is it generalist researcher that gets interested by AI and want to get your knowledge to put it into their knowledge base, or is it the other way around? It's like people that know AI and said, I'm pretty sure that I can apply that to this technology, and or maybe both. I actually don't know.
So for my team, how it's set up, it's really, the idea is that all around us in the different Helmholtz research centers, there are many researchers that are field specialists. So they are, I don't know, researching on, indeed medical imaging,
Mm,
or infectious diseases or
mm,
cancer. And they are super deep into, like, one specific research question, studying one mechanism
mm,
for one disease. And they are acquiring data, like, or making experiments, for example. Um, and the data we get is, so I think roughly, I would say one third medical imaging, another third is omics data. So
mm-hmm.
kind of all this data that is coming from sequencing. Um,
Okay.
so you have gene sequencing, but you
Yeah,
can
the
also
gene.
get
Yeah, yeah, yeah.
the
Mm-hmm.
gene, but also, like, you can sequence a lot of other things in the cell, like the gene
Interesting.
expression, for example, and also proteins and so on. You can
Mm,
also sequence and see how they are structured. So this is also like one third of the data that we get typically. And then the other third is a lot of different things. So we have also like time series data. So for example, ECG, uh, more clinical
I
data sets,
understand
so
the
like
machine
kind of
learning part
scanner.
now. You
Yeah.
get a
So
ton, a ton, a ton, a ton of different formats. So I understand the label. You need to put them in some boxes to be able to treat them. Is it what you meant at the beginning?
so then each type of data typically corresponds to different analysis methods. Yes. So for
Okay.
example, for images, you will not use the same tools typically as you would do for omics data or for like clinical scalar data.
Mm-hmm.
Uh, and so this designs a bit the kind of pool of methods that you have available. Yeah, so this is the data we get. And then I would say there is kind of two. So, and then there's a question associated to it,
Mm,
right? And I think we have two, I think two types of projects. So the first one, they are really about trying to get more insights into the data. Thanks to the data and the machine learning algorithm, understand the process better, like the process that is underlying basically
mm-hmm,
the data generation. And the machine learning is just one tool to answer a question, a biological question. And the other projects that we have are maybe you can relate a bit more to that. I think they are like kind of standard projects where we try to streamline some data analysis that they would have in more
mm,
of a regular workflow. So, for example, like if we have partners who are acquiring on a regular basis microscopy images,
mm-hmm.
and they always want to, in these microscopy images, count the cells that they have, or count
Okay.
the cells, and they have, let's say, different types of cells or
Mm,
whatever, before they would do it manually.
mm,
And there with AI, we can just try to automatize that, and they will save
mm,
a lot of time. They will be able to do a lot more experiments. So we are really
mm.
helping by enabling this high throughput
Okay.
experiment. Uh, but with the algorithm, we are not directly answering a research question. It's more like a tool to
Yeah.
speed up the process.
I understand there is a bit of a part of automatization of some process, but using maybe a lot of models and a lot of experience of a researcher that can say this is right, this is wrong, and train a model. And the other one will be we have a questions and we want to see can we get more data to continue the thinking process. Is it a bit this too?
So the automatization part, you can more relate to it because it's also what
Something we
you
use,
can
yes.
you could use, but just
Mm,
that you typically don't use an algorithm. So
mm,
you don't have out there algorithms that automatically recognize super specific types of cells, right?
mm,
Because it's not interesting for this is not what OpenAI is developing currently.
mm,
But you have super good algorithms that recognize, I don't know, cats and dogs and whatever. So
mm,
uploading your images into ChatGPT will not help if you have a super specific question.
mm,
But we use the same technologies. We just like tailor them for these very specific research purposes. So that's the first
mm,
part, kind of this automatization part. And the second part is more like AI algorithm. We can get more insights into the data. So, for example, let's say we have data that is coming from healthy patients and then data that is coming from disease patients. And an algorithm is actually able to tell them apart. Like an AI algorithm is actually able to tell them apart.
mm-hmm,
Then this gives us a lot of information that actually there is information in this data that is
mm,
about this disease, right? And then starting from this point, we dig into that. So
yeah.
what are the actual, we call them features, what are the actual features of the data that make this prediction available, possible, sorry. And yeah, doing that, we learn a lot about the disease itself. And that's kind of this other type of projects that I would I'm trying to describe.
Yeah, okay, no, it's clear. And I was wondering if a lot of your, maybe not client is not the right word, but like if a lot of your research client, I don't have another word for that, but like the person coming to you is not an AI expert. It's actually the case of a lot of us. So how do you onboard this person to such topic, and also keep them along the way because it's someone that have a very strong technical background and needs to be maybe in a situation where they feel I'm not the person that knows the most and I need to learn. And I see a parallel with business because sometimes you have a new team of consultant or even internal consultant or your own team of PMO, then you work with very experienced people. You're in the same situation. So what is the process? I don't know if you have techniques, but even how does it go along that you can use their expertise, but at the same time bridge with what you are doing without creating a sense that they are losing a bit the credibility that they have.
I think it's a bit probably there. It's a bit different than in academia and in industry, because I
Mm,
mean these people that come to us, they are experts in their research field, and they are so highly recognized. And I don't think that they feel like they lose the face because they approach us.
mm,
They are super expert in what they are doing, and we absolutely acknowledge that. And on the other hand, we are experts on the other part,
mm,
the modeling part, the machine learning part. So usually it works quite well. I mean, we recognize their expertise, and they recognize our expertise, and we see that there is a match. So I would say 95%. I mean, there has
mm,
been edge cases, but in 95% of the projects, this is not really a problem. But we have learned, so this communication part is
mm.
essential,
Okay.
and we have learned over time, and we do it better and better, to communicate, to translate, so to really understand their problem, that they will explain their problem in their language,
Mm-hmm.
and for us to translate this into what it means in machine learning terms, and what it means for us, specifically for the data, and to make this all this knowledge actionable. So this is a learning process. See also, let's say for the consultants who start with me, then I do a lot of this. I sit more
Mm,
in the meetings at the beginning of the project, and that's my main role, is to
mm,
translate what has been said by the collaborators into machine learning terms. And after a few projects, this is much easier. And the consultants also know, okay, what type of caveats they can
mm,
encounter, what type of questions they should ask right at the
mm,
beginning to avoid a lot of those pitfalls. It's a learning
mm.
process that, but everybody learns it. So that's yeah, it's our role to part of the role to do this translation. And it's a lot of fun. I enjoy it a lot.
Yeah.
Because once you also get those people, I mean, they are all super intelligent, and then they understand much better actually what AI is and what it can do. Even if sometimes they approach that, and then the conclusion is, okay, we won't do a project together because the
Mm-hmm.
data is not available. The question they have is not, we cannot answer it yet with
Mm-hmm.
the current
The
AI tools. I
technologies.
mean, that happens. They are still super happy because they have the impression that they they
They
learned
moved.
and understood better, and so
Mm.
that's usually a very nice and rewarding process.
Yeah, no, super. And I was wondering also because you have quite a big team and AI is moving at such a big space. How do you also yourself stay up to date, but also make sure that your team grow because they need to teach others. So I guess they need to stay on top of their field and research take a lot of time. And also AI sometimes is, sorry, there's a lot of question, but like, so sometimes AI goes that fast that I would not like them to burn out because there is so many topics to be on top of it. Yeah, how do you manage that?
So it's a very relevant question. It's a permanent struggle and a challenge for all of us, but I think also every single human out there that is doing some kind of AI research. I mean, nobody can reasonably stay ahead of everything.
Mm-hmm.
So that's the first thing, to communicate this to this team. This is okay to not, because it's just impossible. So I think
Mm,
that's the first thing. But then um, I think how we do it in the team is that we rely a lot on exchange within the team.
mm-hmm.
We have regular presentation of ongoing work, and it's also something that I really push for, is that it's not only presenting like solved problems, but actually anything that is like any struggle, any question, anything that is going on, because
Mm-hmm.
that's exactly when another team member can say, hey, I heard this at the conference.
Mm,
Oh, I had another project where I had a similar problem, and then just share the experience, and this
mm,
is then feeding into the current project and so on. So this active discussion of phase, I mean, we can only address this as a team, as a
Mm.
crowd. Then we also, so we try to stay up to date through the projects. For every project, I explained that we have this exploration phase. We should
Mm-hmm.
redo it. Even if we think we know the solution, we redo it just to check the state of the art, because maybe what we would have done 1 or 2 years ago
Has
for this
changed.
project has changed. So we always check, like take the opportunity, each new project, check again the state of the art, because it's a way also to update ourselves. And as a team, we also organize kind of also a bit of journal club. So when there is like a new
Mm.
topic that we deem important, everybody with one paper on the topic, and then we share, like we present it to the whole
I
team
love
and we
that.
discuss. It needs to be very very low level. So basically, you
Mm.
can just open the paper, discuss it, and then, it's an open discussion that starts with the team. And if you manage to have this culture in the team, I think that's really great, because also everybody feels that they are learning,
Mm.
and also,
Mm.
completely open to say, hey, I have a problem there. I don't know how to proceed. First ask the team. I mean, you can try to ask ChatGPT first, then the team. Yes, but this remains a permanent struggle for all of us, and I think that's, yeah, how it is.
But I really like it was also the second guest, Astrid Moss, as she also mentioned, to try to bridge knowledge because it's really where you create the value. Of course, you can mention it after the project, but I really like what you said about sharing the knowledge, even if it's like ongoing. Um, I had also a question because I thought it was interesting in your team. You have ethics specialists, and
Mhm.
I wondered if you can tell us then what are the hot ethics topics in AI at the moment, and maybe more particularly in your field, if you feel more comfortable to talk about your field. But it's unique to have, a consultant on AI. We would feel, oh, they are coding and so on, and then you have ethics people. I don't know if it was your wish or how this happens, and what are they working on, or the debates that exist at the moment.
We are very applied AI team, right? So the ethicists in my team, they are also very applied ethicists. So we
Mm.
are here to work together on. They are here to work together on the concrete question that is asked by the collaborators, and so they are here to accompany the design and the development of all the AI projects that we have that potentially can have an impact on patients down the line. So, for example, the example that I described with, let's say, automatic analysis of microscopy
Mm.
images of cell cultures and so on, this is not something that where we would involve an ethicist,
Mm.
because we don't, yeah, potentially don't see big ethical
It's a yes
impacts.
no question. Is it distils or not? Question mark.
Yes,
Like,
yes. And yeah, I mean, okay, of course, if you there might be potential biases and so on, but this is quite yeah, a bit more remote. But for the projects where we are kind of designing the first proof of concept of something that could be like called a diagnostic tool, so like projects that are looking at patient cancer data or
mm.
something, and where we are looking for what we call biomarkers, so kind of shortcuts like machine learning algorithms, but that are
Mm.
basically designed to do a diagnostics in the end, of things that can potentially have an impact on the patient down the line. um, I really think, and we really think also with other with our collaborators, our ethicist collaborators, that it's actually important to think about it from the design and not just trying to fix the ethics problem afterwards. And this approach is called embedded ethics. It's not been invented by me. It's also published, um, and this is what we want to implement. In my team, we are also um, concerned by another aspect. We address it more like it's more like research that we do on
Mm-hmm.
it. It's the sustainability of AI. So,
Okay, super
I
interesting.
mean, Yeah, so currently the business model development of AI is highly unsustainable. I think now people are starting to be a bit aware of that. We see a bit now and then in the news, kind of, numbers about, the exploding
Mm,
computation, energy consumptions, and so on of the data
mm-hmm,
centers, and that there are, places and countries where it becomes very worrying. So I think
mm,
the general public now is starting to become aware of that, even though, the academic research at our scale, we are not a significant CO2 emitter compared to big tech companies. We still believe that the current focus of research, also of research on AI, has been primarily focusing on the performance of AI algorithms
mm-hmm.
without looking beyond things like their efficiency and
Yeah,
so
the
on.
optimization in order that it does the work, but maybe more efficiently, not just the
Yes, so
results.
yeah, and aspects about energy consumptions and so on. And then from an ethical point of view, the question of is a given AI application worth developing given its potential environmental impact is also kind of an ethical question that we can address, but it's slightly more philosophical probably.
Mm,
And so we also research along these directions. You also ask about more general
yeah, what are
like
the
ethical or
debates?
philosoph. So I think there are the debates that AI also is also bringing currently into research. I mean, there is more and more tools that are claimed, to be reasoning. So
Mm,
ChatGPT is reasoning. So what is actually scientific reasoning and understanding, and is this challenged by AI, or are these AI
mm,
tools kind of doing anything that approaches scientific reasoning and understanding? This can be like kind of open research questions, I would say. Then how much, like, if we use these AI tools a lot in scientific research, how much can this bias or skew research? I mean, how are we also going to bias towards certain scientific questions and
mm,
also certain ways of solving problems? So I think there are also, I mean, these questions also hold for society, right? If we now
mm,
start using ChatGPT, we will have a very uniform way of thinking
totally.
in society. So this is also relevant for if we start to do a lot of research with AI tools. And there's now a lot of AI. So this basically tools that are enabling to write papers. So AI
Mm,
generated papers and knowledge.
mm,
And then no, there are tools that also offer to review uh,
yeah,
research papers. So then what is the status of like AI reviewing AI generated
AI,
research
yes.
papers? Yeah, and then also another question, I think for me, also in the medical field, but I think not only, is like, what is the impact of AI on learning? So for kids, for medical doctors, for like, all these tools that are
Mm,
available, what is the actual impact on learning and new skill acquisitions if you are always assisted from
yes.
scratch? I think neuroscientists and so on, from the neuroscience point of view, is also very interesting.
It's so interesting, and I think we'll not solve it now. So I will leave all that open because it's like such a good also questions to maybe even discuss, with leadership team or people around you. So I'll close up the part one here. Thank you so much for your time, Marie. So it will be the end of the podcast. So as always, if you like the podcast, put some good rating and some comments, and we'll see each other in the next video. Thanks.